So you have a cuboid of dimensions 7 into 5 into 3 centimeter. So I'm just drawing a cuboid here. So this is 7 times, okay, I'm just drawing a rough figure, okay. So this is 7, this is 5, this breadth is 5 and the height is 3. Okay, and it's painted red, green and blue on each of the opposite faces of the dimensions given respectively. So let me change the color so that it's easy for you to understand. Let's take the red one. Which faces are painted red? 7 into 5. Opposite faces. Each pair of the opposite faces of the dimension 7 into 5. 7 into 5 means what? Let's say I'm just drawing the 3D figure here so it's easy for you to understand. See? So this one, 7 into 5, this one. I'm just making it clear. This one, the entire one is painted. Also the above this one, the opposite one, right? This also it's painted red, right? Both of them are red. And then you have green color. Let's take this one as green, okay? So green color, which is painted green, this 5 into 3 centimeter, both the faces, which is 5 into 3. 5 into 3 means this one. See, this is 5 into 3. This face is 5 into 3. And opposite to that, see, this is also opposite. Okay. These two are painted green. And one more blue is there. So remaining two of them are painted blue color, right? Which is 7 into 3. 7 into 3 means this one. See, this one is painted blue. And the opposite to that, this is also painted blue. Okay. So I hope you got an idea, right? How it works, like how you are painting this cube. Now let's get back to the question. Then the cuboid is cut and separated into various cubes, each of the side length 1 centimeter. So I'm cutting this entire cuboid into cubes of 1 centimeter. So that means I know that this entire height is 3. So I'm cutting into 3 pieces, right? 1 centimeter means it's cutting into 3 pieces. 1, 2, 3. Each one of them is 1 centimeter each. So this is the first cut I'm making. Similarly, I can say that this is also cut, right? 5 is the entire length. This is also cut into 5 pieces. Let's say 1, 2, 3. Not clear, like the it's not exact. I'm just giving an idea, okay? 1, 2, 3, 4. One more cut is needed. Let's say I'm cutting it here. Okay, so you have 1, 2, 3, 4, 5. This 5 centimeters cut into 1 centimeter each. Similarly, this is 7. That means it's cut into 7 cubes. So let's say this is 1, 2, 3, 4, 5, 6. So total 7 cubes will be there. 1, 2, 3, 4, 5, 6, 7. Got it? So similarly, you can see this is also 5. Let's say 1. I'm just want to make it more clear for you. Okay. 2, 3, 4, 5, and here also it's gonna be like this. 1, 2, 3, 4, 5, 6, 7. Yeah. So this is how you are cutting the entire cuboid. So total, it's cutting into cube of 1 centimeter length. Now there are few statements given. We need to check which one of them is correct. Let's start with the first one. There are exactly 15 small cubes with no paint on any of the faces. So can you tell me total how many cubes are there? See, there are 3 rows, right? Row 1, row 2, row 3. In first row, you have 7 into 5, which is 35. Times each row, you have 35 each, right? So total number of cubes you are getting is 7 times 5 times 3. This much cubes are your total number of cubes you are getting. So it's going to be 35 into 3 is 105 cubes are there in total, the small ones. And the question is asking, out of this 105, there are exactly 15 small cubes with no paint on any of the face. That means I need to find how many of the cubes are hidden here that you are not able to see them. If you're able to see them when you paint it, that means it will one of the at least one of the face will be painted. So I need to figure out how many of them are hidden, that is not in your visibility, right? That's what I need to figure out. So there are two ways you can do this. You can use logic, because I can clearly say that any cube in the first row definitely will be all the cubes in the first row. First row means this one, right? There are 35 cubes here. Definitely one of the face will be definitely painted, because you will be able to see, right? Also in the last row, same, at least one of the face are visible here in all the cubes in the last row. See, either the bottom one, all you can see that all the cubes in the last row, the bottom face is clearly visible. So definitely one of the face is already painted. So I don't need to consider in the first row as well as in the last row. I don't need to consider. So the cube should be there in the middle row. So I need to figure out how many cubes are there in the middle row, which is not visible to us. That means I need to subtract the cubes in the border. That's what I need to do, right? So total there are 35 cubes in the middle row. There are 35 cubes in the middle. Each row there are 35. So in the middle row there are 35. Out of that, how many of them are visible, or how many of the cubes are there in the border? So clearly I can say that there are 7 cubes in this border, right? 7 of them are there. And on the opposite side also 7. So you have 14 of them are clearly painted. 14 of them. And clearly on this side, if I'm taking this side, these two are already counted, because this is same as this one, right? These two are already counted. So you have 1, 2, 3, 3 extra, which is painted. Also on the opposite, there are 3 extra. So 6 more extra. So I can see that out of 35, 20 cubes are painted in at least one of the faces. So the number of cubes that are not painted is nothing but 35 minus 20, which will give you 15, which is actually true. So statement or conclusion, statement 1 is actually true here. So this is one way you can solve it. You figure out visually what are the cubes which are not visible to us. Okay, that's one way of solving it. Or what you can do is you can use the concept here. You just need to remove all the cubes in the border. Got it? That's what I need to do. All the cubes in the border I need to remove. So there are total 7 in this length. There are 7. So if I'm subtracting 2 here, so 1 cube will be there in this border and 1 is there here. So I can say it's going to be 7 minus 2. Similarly, if I'm taking along the breadth wise, there are 5. Out of that, 1 is there in the border here and 1 is here in the border. So I'm subtracting 2 here from that. And about the length, height wise, total is 3. So out of that, 1 is definitely in the border and this is also in the border, right? So only 1 is there left. So 3 minus 2. Then you need to multiply. This is also another way to do it. So it's going to be 5 times 3 times 1, which will give you 15. So this much cubes are hidden, or these are the cubes that is not visible to us in any viewpoint. So what we did here is we just removed the cubes at the border. So in the border one or in the surface one, the cubes definitely one of the face will be selected, will be painted. So that's the logic we did. We subtracted 2 from each dimension. Length, breadth and the height, you subtract 2 because we are not counting the cubes at the border or the surface ones. So that's how you're getting 15. Or you can use this approach. Logically think about it, okay? And figure out how many of them are not painted. So first one is correct. Now let's try the second statement. There are exactly 6 cubes with exactly 2 faces, one painted with blue and one with green. So I need to look for blue and green painted on exactly 2 faces, okay? So I can see this is one cube, right? This one. Definitely one face is exactly one of them is painted blue and one is green. Similarly, you have the same in this. Also on the other corner, 2 corners, you have the one, right? That's it. There are only 4 cubes, smaller cubes, which has exactly 2 faces painted. one with blue and green. 1, 2 on this corner is 1 here, and also you have here also you'll have 1. So total 4. If you consider this one, there are 3 faces painted. Also in the corner here, there are 3 faces painted. You look for exactly 2 faces painted. So your answer is 4, but here in statement 2, it's given that 6, which is not correct. So I can say that statement 2 is wrong. It's not correct. So out of the 2 statements, option A is the right answer. That means only statement 1 is true in this case.